In the previous discussion, we actually mentioned about the symmetry of the graph. Right, so in this lecture, we are going to perform a symmetry test of function. Now, it means that we are going to test the function, whether the function is symmetry with respect to x, or the function is symmetry with respect to the origin. Now, let's start with some revision first. Now, if we have a graph like this, so the graph, we say the graph is symmetry with respect to y. Okay, the reason is, all right, the y serve as a mirror and left, right, they are equal. Okay, the value of left and the value of y of the graph, they are equal. Now, when we have a graph like this, we say the graph is symmetrical with respect to origin. Now, why? Because the origin, this point, serves as the mirror. So when we have a point here, it will actually reflect to this point. Okay, so this point will reflect through the origin and come to this point. So the point serves as the mirror for the reflection. Therefore, we say this is symmetry with respect to the origin. Okay, now how about if a function is like this? Okay, so we can see here the y-axis will serve as the mirror and the graph above the x-axis and the graph below the x-axis, they are actually symmetrical. Okay, so the x-axis serves as a mirror. Now, however, when we talk about function, all right, this is not a function because one value of x will give two values of y. Okay, when we substitute, let's say this value is 2. So one value of x will give us two values of y if the graph is symmetrical with respect to the x-axis. Therefore, right, this is not a function, and from our discussion here, right, so this will be excluded. So we are going to discuss the function, right, symmetry with respect to y, and the function symmetry with respect to the origin. Okay, now the function is even function if the graph is symmetric with respect to the y-axis. Okay, so it means that if the function is symmetric with respect to the y-axis, okay, we say this is even function. Now, when the graph is symmetric with respect to the origin, we say it is odd function. Okay, for example, x, y. Now, if the function is like this, okay, we say the function is odd function, right? Because the function is symmetry with respect to the origin. Now, how do we perform a test without a graph? Now, if we substitute f negative x and the y we get is same as fx, okay, then we say the function is even function and it is symmetric with respect to the y-axis. Okay, now we can see here, if we substitute a value of x, we get a value of y here. Now, if we substitute negative x, we get the same value of y. Then we know the graph is even function and it is symmetric with respect to the y-axis. Okay, now if we substitute the negative x, the negative x, and the y we get is actually the negative y. All right, so the y is fx. So this is negative fx. It means that this is negative y. So if we substitute negative fx, we get negative y. Then we know the function is odd function. So let's see here. If we substitute x here, so if we substitute x here, we get y. And if we substitute negative x here, we get the opposite, negative y. So then we know this is a odd function. Now let's take a look on the example here. All right, so we need to determine whether the function is even, odd, or neither. All right, and then we need to find the zeros of the function. Okay, so first we are going to perform the negative x test. All right, perform the negative x for a. So substitute negative x into the function. So we have negative x to the power 3 minus negative x. So what do we get? So we will get negative x to the power 3 plus x. Now, is this function same as f? No, this is not fx. Okay, obviously this is not fx. So we will say this one, f negative x is not fx. So what is the conclusion here? All right, so this is not even function. Okay. Now, however, we can continue to check if this is odd function. So when we extract, we factorize out the negative x, we will get this one. All right, so extract, take out the negative, we have negative x to the power 3 minus x. So is this function fx? Yes. All right, so this is negative fx. So now we know that the f negative x is actually negative fx, so it satisfies this condition. Okay, so it satisfies this condition. And now we can say, all right, fx is odd function. Okay, so this is how we determine. So we know that now the fx is odd function. Okay, let's proceed to g, function g. Okay, before that, now we're supposed to find the zero of the function. Now the zero of the function means that when the function is equals to 0, what are the possible value of x? So in this case, we factorize out the x, and we have x squared minus 1. So then x is 0, right? X minus 1 is 0, and x plus 1 is 0. So we have x equals to 0, 1, and negative 1, and this is the 0 of f. So actually, if we sketch a graph of function f, right, the function will f looks like this. It is an odd function with the 0 of f, negative 1, 0, and 1. Now let's continue with the question B, the gx. So gx is 1 plus cos x. So as usual, we perform the test with negative x. Substitute inside here. Now, we can see here actually cos x is equals to cos negative x. Okay, so now in this case we have 1 plus cos x, and this is actually equals to gx, and from here, very obvious, we know that the function g is even function. All right, so now to find the zeros of g, so we let the function be 0. Right, so the cos x is -1. So if the cos x is -1, then we know that, right, the x will be 2n plus 1 pi, the n is an integer. Okay, now let me explain about this. All right, now, so first, cos x equals to -1. All right, what value will give us cos x equals to -1? Now, if you're familiar with the graph, right, the graph of cos actually goes like this, right? Okay, so this is 0. This is pi over 2, which is 90. This is pi, and 3 pi over 2, and this is 2 pi. Okay, now when the cos x is -1, so it's actually here. All right, so we know that, all right, the value is pi. Now, so the x here will give us pi. Okay, the value is pi. Now, however, right, when we talk about the rotation, okay, this is 0, this is pi over 2, this is pi, 3 pi over 2. When we talk about rotation, okay, rotation. Now, when we rotate here, sorry, when we have the graph here, all right, then when the rotation is here, right, when the angle is pi, then we get the cos x is -1. Now, the rotation can continue to have another round. So, in this case, we will have pi plus 1 round, which is 1 round is 2 pi, right? So we have pi plus 1 round, pi plus 2 pi. Now we can continue the rotation. So it will be pi plus 2 round. So we will have 2 times 2 pi. Okay, and we can have 3 rounds, right? 3 times 2 pi. Now, so in this case, all right, we can see here, okay, so we actually can extract the pi out, all right, and let the n be, this value be n. Okay, we have the n here. So this value, they are n. All right, so we extract the pi out, so we have n. So we have 2n plus 1. Okay, so take out the pi. Okay, this is the n. So we have, okay, 1 plus 2n actually. So it's actually 2n plus 1. All right, 2n plus 1 when we extract the pi out. So in this case, right, the n is any integer, and when the n is 1, then we will have this. When the n is 2, we will have this. When the n is 3, we will have this, and so on. All right, so in general, all right, so the x will be 2n plus 1 pi, where the n is any integer. Okay, so if we look at the graph will look something like this. Okay, so this is the pi. All right, so, okay, plus 1. So then we will have this pi here, right, and 3 pi's and so on. Okay, so this will be the 0 of graph.